In today's class, we're going to continue from where we stopped on last class, which is the trig identity and trig equation. Okay, so the first question we're going to consider here is trigonometric identity. Okay, where we have to show that the left hand side equals the right hand side. So I told you one of the critical steps when you are asked to prove for something is to know the right side to start your proving from. Okay, so by looking at this now, you should know that you're going to start the proof from the left hand side. Okay, so from the left hand side now, LHS, so we have tan theta, all right, then over 1 plus cos theta plus tan theta over 1 minus tan cos theta. So when you look at the right hand side of what you have to show, the right hand side is in terms of cos theta and sin theta. So you should know that you just have to eliminate tan theta here. Okay, you have to eliminate tan. So but first thing to do is to reduce these two fractions to become a simple fraction. So and the best way to go about that is by taking the XAM, that's 1 plus cos theta and 1 minus cos theta. All right, so this is going to be tan theta in brackets 1 minus cos theta, then plus tan theta in brackets 1 plus cos theta. Okay, so let's simplify the numerator. So by the time you expand the first bracket, it becomes tan theta minus tan theta cos theta. Expand the second bracket, you're going to have tan theta, then plus tan theta cos theta. All right, then over everything divided by what? By 1 plus cos theta and 1 minus cos theta. Okay, so when you look at this cancels this. Okay, so then you left with tan theta plus tan theta, that's 2 tan theta, then over what? 1 plus cos theta and 1 minus cos theta. So what's going to happen here? The denominator here now form difference of 2 squared. I told you anytime you have a minus b, a plus b, this is going to be a squared minus b squared. So by implication, this becomes 1 minus cos squared theta. All right, so you just have to know this and to waste in order to waste time, you understand, to manage your time effectively. Okay, so you have 2 tan theta here now. Okay, so what's going to happen here now? We've all agreed that we just have to eliminate tan. There's no doubt about that. Okay, so but before we do that, what you have in denominator can be written as sine squared theta. Yes, because sine squared theta is the same as 1 minus cos squared theta. That's the first identity. All right, so now we can now change tan to be in form of what? Sine over what? Over cos, then divided by what? Sine squared theta. So by the time you use reciprocal law now, this is going to be 2 sine theta cos theta multiplied by 1 over what? Sine squared theta. All right, so one of these signs cancel this, then you now left with what? 2 over cos theta sine theta, and that is what we are to show for. So that's the end of the question. Okay, so moving on to the next question, which is B part of the first one, and what we have there is a continuation where we have to solve the equation now. Okay, so the only difference here is that they change the right hand side of the identity. Okay, so the left hand side remains the same, so which is tan theta over what? 1 plus tan theta, 1 plus cos theta, 1 plus cos theta, then plus tan theta over 1 minus cos theta, then equals 6 over tan theta. So the left hand side of this equation, that is what we've gotten here to be 2 over cos theta sine theta. So we can just remove that and put 2 cos theta sine theta. And 6 over tan theta can be written as 6 cos theta over sin theta. So now look at this. You do a great mistake if you decide to cancel the sin theta out here. That would be very wrong to do that. Okay, so you don't just cancel like that, because of course theta here is a unknown variable. So what you have to do now is to cross multiply. Then you have 2 sin theta equals 6 cos theta cos square theta sin theta. Of course you can cancel 2, you can divide both sides by 2 because that's constant. So this is sin theta now minus cos square theta, minus 3 now, then sin theta. Like I said, you don't cancel sin theta here because theta there is the unknown variable. So you could factorize sin theta, and then you have 1 minus 3 cos square theta equals 0. Now for product of two factors to be 0, so one of the factors must be 0, meaning that sin theta equals 0, or 1 minus 3 cos square theta equals 0, which can be reduced to cos square theta equals 1 over 3. Exactly. So for sin theta to be 0 now, theta must be 0 degrees. Then cos square theta now can be written as root 1 over 3, or cos theta equals minus square root of 1 over 3. Exactly. Now cos inverse of that will give us 54.7, and cos inverse of minus root 1 over 3, that will give us 125.3 degrees. Okay, so but then let's look at the domain. Let's see what we have to find. Now the angles must be between 0 and 180. Remember, 0 and 180 are exclusive. Okay, are excluded here. So it means that we are not going to consider 0 degrees as part of the angles here. So we only take 54.7 degrees and what? 125.3 degrees. So that is the solution there. So yeah, for those, if you decide to cancel sin theta here, you still get the same results. And the reason why you get the same result is because 0 degrees is outside the angles you are expected to get. If perhaps the domain here is from 0 less than or equals to theta less than or equals to 180 degrees, then doing cancel both sides by sin theta will be a great mistake. So in the process of solving it, right, please note that it's very important. Now let's move to the next question. So okay, we have to show that 1 plus sin theta over cos theta plus cos theta over 1 plus sin theta equivalent to 2 over cos theta. Okay, so of course you all know that here now obviously we are going to start from the left hand side. So our first thing to do there is to take XAM. So XAM there is going to be cos theta times 1 plus sin theta. Then you have 1 plus sin theta times 1 plus sin theta, that's 1 plus sin theta squared, cos theta squared as well. So you expand that, that's 1 plus 2 sin theta, then plus 2 sin square theta, cos square theta. Alright, then over cos theta, 1 plus sin theta. So don't expand the brackets yet. Let's see how the numerator is going to look like after we reduce it. So sin square theta plus cos square theta is 1. So 1 plus 1 you have 2. Then this is 2 plus 2 sin theta. Then cos theta, 1 plus sin theta. So again, 2 here can be factorized. So you have 1 plus sin theta. Then over cos theta, 1 plus sin theta. So now this cancels this. So you have 2 over cos theta. That's that. So let's look at the B part of this question. Okay, so part B of the question is given as this. So what's the question? hence solve this. So we don't need to stress ourselves. We've gotten an expression for the left hand side here. Everything here we've gotten that to be 2 over cos theta. So just replace that to be 2 over cos theta. 2 over cos theta now equals 3 sin theta. So then we cross multiply. This is 2 sin theta equals 3 cos theta. So what are we going to do here? Separate the trig ratio from the constants, which can be written as sin theta over cos theta equals 3 over 2. So I obtained this by multiplying both sides by 2 cos theta. So, and of course, sin theta over cos theta is what? Tan theta, which is 3 over 2. Exactly. So tan inverse of 3 over 2. Mind you, the domain here is in terms of radians, so you should always leave your answer in radian. So tan inverse of 3 over 2 will give us 0.983 rad. So when the angle is in terms of radian. So the next thing to do now remember this is the domain now. Okay, so this result that we obtained, now you add another 180 to this. So 180 is equivalent to pi. So if we add pi to this, pi which is equivalent to 3.142, so this is going to give us 4.13. So sorry, these are the two angles you're going to obtain here, which are in terms of radians. Exactly. Okay. So let's take this last question now. So prove this identity. Okay, so yeah, let's start from the left hand side as well, because we have two simple fractions the left hand side. Okay, so sin theta, so I think the first thing to do is to take XAM. Yeah, let's take the XAM, which is sin theta plus cos theta, then sin theta minus cos theta. All right, and this becomes sin theta in bracket sin theta minus cos theta. So plus cos theta in bracket of what? Sin theta plus cos theta. All right, so expand the numerator now. That's going to be sin square theta minus sin theta cos theta. Then expand the second bracket, that's sin theta cos theta plus cos square theta. So this cancels this. So I told you what you have here, sin theta plus cos theta, sin theta minus cos theta. That can be written as the difference of 2 squared of sin squared theta minus cos squared theta. So when you look at the numerator of this expression, we are left with sin squared theta plus cos squared theta, and that's going to be what? 1. Sin squared plus cos squared is 1. Then over sin squared theta minus cos squared theta. Okay, so the question is that what are we going to do from here? If you look at what we are trying to show, for the right hand side is in terms of tan, and the result we obtain here is in terms of sine and cos. So what we're going to do is to divide this by cos squared. You understand? We divide this by what? By cos squared, because it's only when you have sine over cos that this becomes tan. Okay, and we need sine squared over cos squared for us to have tan squared theta. So okay, if you divide this, we only have 1 over cos squared in the numerator. That will not make sense. Okay, I think we should go back to, let's maintain sine squared and cos squared here. So maintain sine squared theta plus cos squared theta. Let's maintain that. So we can now divide the numerator by cos squared theta and denominator by cos squared theta. Exactly. So by the time you do that, this should be sine squared theta over cos squared theta, then plus 1. Then denominator becomes sine squared theta over cos squared theta minus 1. So this now becomes tan squared theta plus 1 over what? Tan squared theta minus 1, and that is the end of the proof there. Okay, so I think we should just consider the B part of this question, or okay, let me just do that as assignment. So just do the B part of this question and drop your answer at the comment section of this video. So don't forget to like, comment, and subscribe. Thank you. Bye.